Okay, let's one more. We'll do it. Nucleus A decays to B with a decons lambda 1 and B decays to C with this one. So A decays to initially at T equals 0, number of nuclei of A is 2 N naught, that of B is N naught, and C is 0. At some instant T equal 10, number of nuclei of B stops changing. Find T naught if at this instant number of nuclei of B are 3 N naught by 2. Stops changing. What do you mean by that? Stops changing. Stop changing means, so this is at some instant T equal to T naught. This will become constant, no? Shall we put like this? So first we'll write the rate equation for B. dNB by dt should be equal to lambda 1 Na minus lambda 2 NB. Is that okay? I think by this time all of you are having enough idea how to write rate equation. Rate of formation of B is equal to rate of production of B minus rate of decay of A. The rate of production of B is what? Rate of decay of A. Finding very difficult, go for tanks, draw that. So now what is the basic condition is put? The time at which NB remains constant. So NB constant means dN by dt should be 0. So this I'll put 0. What is NA? NA at any instant of time, can we write? And what is NB equal to? NB equal to 3 N naught by 2. We know value, NB is equal to, so I'll substitute all, and lambda 1, 2 N naught e to power of lambda 1 t minus lambda 2t N naught by 2. Shall write T naught? Yeah. Solve for T naught, we'll get the required answer. So I seen maximum, the moment you don't end up with mathematics, I think, so this is what the central idea, the most of the numericals will revolve around this rate equation. So writing rate equation is highest priority. That's why you check the advanced paper, almost 5 times he's asking rate equation, write rate equation, write rate equation. Then he's asking some other thing. It's stressing, means students, somehow you focus on this. Once you know this, then conditions and mathematics. If you go wrong here, nobody can help you, no? See, unless you don't get this, not possible. So how to write this equation? At least minimum some. Okay, try this diagram like this. Or logical tanks. So writing rate equation is successive. Disintegration is something very important. And suppose say A, it is having 2 N naught. Okay, that one. So it is not being produced, no? It will start decaying. So if any substance, if it undergoes decay, then you know this decay equation. Proceed with this. And B is what? Produced and also undergo decay. So like this, you can write rate equation. And C is what? Stable. So what all the B, what happen? How to calculate the number of nuclei of C, anything? After getting this T naught, so can we calculate NC? As we can do, no? So what shall we write here? 2 N naught plus N naught should be equal to, shall we, is it justified writing this equation? Or only 2 N naught, as the overall population should remain same, no? So we know this is 2 N naught. It didn't ask, okay, I can go for further like this, 2 N naught e to power of T naught. I'll solve for this T naught value, I know it, substitute, I'll get the population of C also. What is this? So slight logic, so nothing to do with our what, sir, I don't know binding energy. No problem. Sir, I don't know nucleon. No problem. Radioactivity is nowhere related to nuclear physics. Make things clear. Only alpha, beta decay comes that nature of radioactivity is something constant, but numerical solvent doesn't need anything about nuclear physics. They're just based on logical thinking. And he has given priority in the advance. You check it. Maybe it's testing even your logical ability also. I'll write the equation for T naught. Population of C also you can find out. Work out later on. Huh? This will be our answer. This is a rate equation. Oh, completed a whole. Okay, now we'll see. Remaining will continue tomorrow. Huh? Okay, thank you all
Sir,
of you. Yeah.
sir, in the last page once, can you go again?
I think we are here. Yeah.
Sir, here can we write the population of C as lambda 2 into NB into
So, number decade. How you calculate number decade of B? Number
sir,
decade.
C is nothing but the amount of, can we write lambda 2 into NB into T?
What is NB? Tell me first of all. You tell me what is NB. So
Amount
again,
of,
again, what happened? You should go to the tank idea. At least look at the tank and try to develop the idea now. Now it is like this. This is C. This is B. This is A. Initially, this is no. At any instant of time, I'll give some time. I'll rearrange things. Okay, look at now. This is A, no, and it will become B. And that this is C. What is C? What is this liquid C?
amount of B which is getting decayed.
For that, what happen? What you should do? I don't want to give answer. I want you to generate answer. Tell me like this liquid, blue color liquid is what? How much of liquid A decade minus how much is present the liquid B is what? C, no?
K of B.
Okay, no, write equations. See. Okay. There's a population of C. Okay, I'll wind up the class. Huh?
Sir,
No, yeah. Yes, anything?
So rate of formation of C will be rate of decay of B. No, sir. Why we are not taking that
Yeah,
equation?
that only you can write it. Rate of decay of B, and you know expression for B. You have to generate again expression for B at any time t. We are discussed at t equal t naught where it stops. This was the equation. Again, what you should do, you should go back to the equation successively. NB is equal to lambda 1 n naught by lambda 2 lambda 1 minus lambda 2 e to power of minus lambda 1 t minus e to power of minus lambda 2 t. From that, you'll get the population of B at any time t. Then you should come there.
Both will get same answer.
Yeah, that one. But we are discussing our entire problem when the B stops. The moment B stops, it's telling B will stop here. So that